So we are going to discuss 2026 January Chemistry Unit 1 paper, and we are going to discuss the MCQ section. So the first question they are asking, which property determines the order of elements in periodic table? So if you take the first few elements in the periodic table, we know that first element we get hydrogen, after that we get helium. Then the third element we have is lithium, beryllium, and you can see that hydrogen has number of 1 proton in its nucleus. Helium has 2 protons in its nucleus. Lithium has 3 protons in its nucleus. Beryllium has 4 protons in its nucleus. And if I take the next element, boron has 5 protons in its nucleus. So the elements in the periodic table is arranged based on the number of protons in the nucleus. So therefore our answer for the first question is D. Let's move on to the second question. Second question asks, which atom has the most orbitals that contain single electron? So they are asking 2 conditions here. First of all, you should find the atom with single electron. And you have another condition, it should have to have most orbitals. If you check your periodic table, carbon atomic number, that means number of protons in its nucleus, is 6. Nitrogen atomic number is, right after carbon, it's 7. Chromium atomic number is 24. Manganese atomic number is 25. So when we look at these numbers, we know that number of protons is equal to number of new electrons if the atom is neutral. So which means if carbon has 6 protons, the number of electrons of that carbon atom is 6. So same way, number of protons is equal to number of electrons when the atom is neutral. So therefore, the number of protons we have here is same as the number of electrons they have. But they are saying that which has most orbitals. So we can clearly see that when you have more electrons, you need more orbitals. So therefore, obviously, carbon cannot be my answer because it has very few number of electrons. Nitrogen also cannot be my answer because it has only few number of electrons. So then we are left out with chromium and manganese. And if we check the electron configuration, chromium has 24 electrons, manganese has 25 electrons. If I write the electron configuration of chromium, it's 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. We know that 4s shall get filled before 3d shell, then will become 3d4 because we came up to 2 plus 2 is 4 electron, 4 plus 6 is 10, 10 plus 2 12, 12 plus 6 is 18, 18 plus these 2 electron 20, 20 plus 4 is 24. And when you go for next one, manganese, it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d5. Right. So now we have these 2 electrons, but there is some small condition. If you look at the electron configuration of chromium, we know that it has 4s2 electron configuration and 3d4 electron configuration. 1, 2, 3, 4, 5. So if I write the electron configuration arrangement in chromium is 4s2 and 3d4. In this type of scenario, in your syllabus you have to learn this special scenario in chromium and copper. So same thing happens in copper. Because you can see that in chromium, to fill this 3d subshell completely half, that means to make it 3d5, you need only 1 electron. So what will happen? One of the electron from 4s subshell slowly move into this empty 3d subshell. Therefore it will become 3d5. Since that one electron is gone from 4s subshell, now the electron configuration of 4s subshell will become 4s1. So the electron configuration of chromium is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. Manganese electron won't change, electron configuration won't change, so it will look like this: 3d5, 1, 2, 3, 4, 5, and here you have pair of electron. Since the 3d subshell is completely half filled, manganese will not do such a change. The same change will again happen in copper. I just tell you this part, that section also here. Copper electron configuration is 29. So 29, if you write the electron configuration, you get a scenario like this: 3d9 and 4s2. So if you draw how the orbitals are filled, you have 2 electrons in the 4s subshell and 9 electrons in the 3d subshell. When you have 9 electrons, you can see to fill this 3d subshell completely, you need only 1 more electron. Therefore, what will happen? From the 4s subshell, one of the electron will slowly move towards this 3d subshell, making it completely filled. So therefore electron configuration of copper also changed from 3d9 to 3d10, and the 4s2 becomes 4s1. These are the only 2 changes that you have to know. They will rearrange the electron configuration for the greatest stability of their 3d subshell. Now let's read the question. Now we don't need copper. Now we have looked at chromium and manganese. It says which atom has the most orbitals that contain single electron. Highest number of orbital which has single electron. I can clearly see that. Manganese has only 5 orbitals with single electron. But if you take chromium, it has this 5 plus 4s1, so altogether 6 orbitals. So therefore my answer for question number 2 is B. Let's move on to question number 3. Which ion is not isoelectronic with the other ions? Okay, so first of all, we have to understand the meaning of the word iso, or some call it isoelectronic. Isoelectronic means same number of electrons. Same number of electrons. So remember that part. So I want to find which is not isoelectronic with other ions. So we have to find what are the number of electrons in each species have. So first we'll think about their neutral atom. So if I take titanium, if you take a neutral atom of titanium, its atomic number is equal to a number of electrons. So you can say that titanium is 22 atomic number. But when you become +3 ion, you are losing electron. Remember, positive charge means losing electron. +3 means it's going to lose 3 electrons. So from 22 electrons, if you lose 3 electrons, 22 minus 3, it will be 19 electrons. So titanium 3 plus has 19 electrons. Calcium atomic number is 20. When it's going to become calcium 2 plus, it's going to lose 2 electrons. 20 minus 2 is 18. Then phosphorus atomic number is 15. Minus means you are gaining electron. Minus 3 means you are gaining 3 electrons. For 15 number of electrons, if you get 3 more electrons, it will become 18. Now you know the answer, because 2 of them are same, 1 is different. So if this first, the B and C having 18 electrons, we can guess D also should have to have 18 electrons. But we'll check. Chlorine atomic number is 17. Chlorine minus means, chloride ion means is get 1 more electron. So 17 plus 1 is 18. So they're asking which is not isoelectronic with the other ions. Which is not, so one which is not isoelectronic with other ions is A. A is our answer, because B, C, D, they have the same number of electrons, which means they are isoelectronic. So answer for question number 4 is A. Now let's move on to question number 5. Question number 5 asks, which properties of a cation result the greatest polarizing power? To understand this question, we should know what is this polarization. Let's assume in an ionic bond, you have the cation and you have the anion. Between them, we have the attraction, electrostatic attraction. Polarizing means these cations pull this anion little bit strongly. So when it pull this electron cloud of the anion little bit stronger, what will happen means this electron cloud will not be spherical. Instead of that, it will be little bit elongated towards the cation. So it gets pulled towards the cation. We call it extent of covalence in ionic compound. Because electron clouds trying to overlap, we call it covalent bonding. They are trying to overlap. So this is showing the property of trying to overlap. So we call it extent of covalency. For this to happen, there are 4 things they should fulfill. Okay, I'll write what are the properties we should have to have in the cation and the anion. First thing is both cation anion both should have greater charge, because more plus, more minus means their attraction is higher. So cation should be also have greater charge. So it should have to have greater charge. Anion should also have to have greater charge. Okay. So high charge means better for cation as well as anion. So therefore, if you take the charge, it should be always large. So either my answer should be either B or C, because in charge wise doesn't matter if it is cation or anion, they should have to have greater charge. But if you take the radius, the size of the anion should be a large ion. Why it has to be large ion? Because our expectation is electron in the anion get pulled towards the cation. So electron goes out of control when the distance from the nucleus, because anion nucleus is the one who holds these electrons close to the itself. But if the electrons are further away, it's hard for this nucleus to control them going away from it. So therefore, anion should have large ion. In the other hand, the cation should have to have a small radius. Small radius, the reason is when it is small radius, the nucleus is very close to pull these electrons, or we can call it has higher charge density. So when the nucleus is very close to this electron, it will only happen when the cation has smaller radius. Then only it can pull strongly these electrons. So cation should have small radius. So in a summary, if you take cation, it should have to have greater charge and small radius. But for anion, it should have greater charge but large radius. It should be a large ion. So if you fulfill these 2 factors, then the cation can strongly pull this electron cloud towards it. We call it polarization or polarizing power. Which properties of the cation, they are talking about the cation, results the greatest polarizing power? Cation should be small radius and greater charge. So when you think that way, it should have small radius and greater charge. So we expect our answer to be C in question number 5. Right. Let's go for question number 6. The first 5 ionization energy of element Z are shown. Now when you look at these numbers, most of the students get confused when they try to figure it out using these numbers. So there's an easy way where you can find the real answer is just plot them in a graphical way, in a graph. So if you can put it here, so here I put number of electrons removed. And in this side I'll put ionization energy. Okay, you don't need to be exactly, but we'll just mark the ionization. So number of electrons, they are going to remove 5 electrons. Okay, first electron, second electron, third electron, fourth electron, and the fifth electron. So let's divide by we go up to 13,000. So it will be 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000, 11,000, 12,000, 13,000. Yeah, we have 13. Okay. First ionization is somewhere 438. So 1438. So instead of 1000, I just put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So all these numbers should be multiplied by 1000, right? Okay. Now first ionization energy is 738. 738 means little bit less than 1000. So I'll just put the dot here. Second ionization is 1450, in between 1 and 2, somewhere here. Third ionization is 7700, it's very close to 8000. So I just put it somewhere here. Fourth ionization energy is 10,000, somewhere here. Fifth ionization is 13,000, somewhere here. So if you can see it, you can see graph goes like this. Then there's a huge gap. This is a large gap. And then it goes like this. So you can see that between second and third ionization energy, first, second, third, there's a large gap. That means actually you can only remove 2 electrons easily. These 2 electrons you can remove easily. If you can remove 2 electrons easily, most probably it will form Z2 plus cation, because it can remove 2 electrons easily. So if it is Z2 plus, and to neutralize this plus 2 charge is need 2 Cl minus, because Cl is -1, you need 2 of them. So therefore, if they ask the formula of the most stable chloride of Z, I will go for ZCl2, because it can remove 2 electrons easily. So ZCl2 is our answer, which means our answer is C. Question number 6, answer is C. Right. Let's move on to question number 7, which is not a neutralization reaction. In this one, you have to understand what is the definition of a neutralization. If you take neutralization, it's the neutralization of an acid with an alkali. Alkali can be strong or weak, both are fine, right? It can be weak or strong alkali. Or a bases. We know that what are the bases are metal oxide, and we know that metal carbonate. These are the metal oxide and metal, those are also bases. So they are saying we talk about acid neutralizing with the alkali and a metal oxide or metal carbonate. So if I take the first one, it's a metal reacting with acid. We never discuss metal reacting with acid as a neutralization. And also, if the neutralization reaction takes place, you should get salt and either water. So the combination is salt and water is what we had, but we never talk about hydrogen. So therefore, this is not a neutralization reaction. A is not a neutralization reaction. It's simply a metal react with acid. So you can call it displacement reaction or redox reaction. But if you take B, it's a metal oxide with acid. Yes, it is a neutralization. C, weak alkali with ammonia. Weak alkali with nitric acid. Ammonia is a weak alkali. So weak alkali react with nitric acid. Yes, it is alkali versus acid neutralization. Metal carbonate with weak acid, but it's a metal carbonate with the acid. Yes, it's a neutralization reaction. That's why our answer is A for question number 7. Right. Now let's go for question number 8. In question number 8, so they are talking about a hydrocarbon. So we know that hydrocarbon means a compound or a molecule which contains carbon and hydrogen only, nothing else. So they say in this hydrocarbon, 82.8% are carbon. So remaining should be then hydrogen. Right. So it says the amount of percentage of carbon is 82.8%. So if carbon is 82.8, the remaining should be hydrogen. So if you do the math, you can find 17.2% should be then hydrogen. So what is the meaning of this percentage? It simply says that if you take 100 grams of this sample, 82.8 grams will be carbon, 17.2 grams will be hydrogen. So how we convert this mass into moles? So we know that how to convert mass into moles. Number of moles equals mass divided by molar mass. Now we have the mass, so we'll find the number of moles of carbon. We have 82.8 divided by molar mass. Molar weight of carbon is 12. Hydrogen is 17.2 divided by molar mass of hydrogen is 1. So if we divide it, your answer is 17.2 here, and here your answer will be 6.9. To get the simplest ratio, what we do here is, out of these two moles, we take the smallest numbers, which is 6.9. We divide the both sides by the smallest number. 6.9 divided by 6.9, it is 1. 17.2 divided by 6.9, it is 2.5. Right. So 1 is a 2.5. If you take it as a whole number ratio, you can multiply both sides by 2. So it will be simply 2:5. So the empirical formula of this hydrocarbon is C2H5. But remember, if you see bold letters in these papers, you have to be careful. As I remember, this same question came in 2015. I can't remember the exact year, but so 2015 the same question came. So it's molecular formula they are not asking empirical formula. But we know that empirical formula times, it might be 1. Empirical formula times 1 is, if you multiply C2H5 by 1, it is C2H5. If you multiply C2H5 by 2, it is C4H10. If you multiply by C2H5 by 3, it is C6H15. So our empirical formula times a whole number will be our molecular formula. I'm not going to more than that because there's only two answers which tallying with this combination, C2H5 times 1 or C2H5 times 2. But remember, when you talk about molecular formula, there has to be a real molecule. Molecular formula comes to the real molecule. So we have learned about two types of hydrocarbons. Let's see whether we can put these formulas. Now we'll take the first one, C2H5. Can I put C2H5 in our hydrocarbons that we know? We know two types of hydrocarbon. One is an alkane. When it is an alkane, there are two carbon and all the others should be hydrogen. 1, 2, 3, 4, 5. Now we have C2H5, but this bond is missing. That means C2H5 cannot exist as an alkane. Let's check then it for an alkene. Alkene, carbon, carbon, double bond. Each carbon atom should have 4 bonds. So if I put this, there's a hydrogen atom in each place. Now it comes as C2H4. I can't put another hydrogen atom. So therefore C2H5 cannot exist as either alkane or alkene. So I think C2H5 is the empirical formula, but it's not the molecular formula. Let's go for C4H10. If you go for C4H10, let's go for an alkane. 1, 2, 3, 4. So we have to put 4 bonds for each carbon atom. So 3 hydrogen, 4th hydrogen, 5th one, 6th one, 7th one, 8th, 9th, 10th. Okay, C4H10 is a real molecule, it's an alkane. So therefore, since they are asking molecular formula, the answer for my question is D. So a hydrocarbon contains 82.8 carbon by mass, which could be the molecular formula of this hydrocarbon. Yes, answer is D. Now you might have a doubt. There are two options. If you have done last 10 years past paper, yes, you will do this question really fast. But the second thing is, this question you might feel it use little bit you have to put extra effort and extra time. So that's your question. Yes, this is a part of this exam. So if you look at clearly, I'll give you the rough idea how this exam works. They will give you 20 MCQs, 20 multiple choice questions. In this 20 multiple choice question, they expect, according to the timing, we can't expect to use more than 20 minutes. So that means roughly we have to use 1 minute per question. But they are saying that this 20 minutes for this whole 20 MCQ section. It doesn't tell you that each question is 1 minute. For an example, what they do is, yes, first question you can use it with 1 minute. Second question, third, they'll give you general type question, general questions. So if you do them in an order, yes, at the end of 10 minutes, you have finished the first 10 MCQs. Now 10 minutes is gone. Now we are left out with 10 more minutes to complete the 20 MCQ questions. But when you go for somewhere question number 11th, 12th, little bit in the middle, they'll put 1 or 2 questions little bit time consuming. For an example, if I take 11th and 12th questions, let's take, they are each take 3 minutes. So that means altogether it takes 6 minutes for me to do this 11 and 12 questions. But 13, 14, 15, 16, 17, 18, 19 and 20, the last set of questions, they have give very simple questions. You don't need much time. So if you add these times, it's a half a minute. So you need only 4 minutes to complete this last 8 questions. But any student who's doing this question in an order, when the student come to question number 12, already 16 minutes gone out of 20. So you have 8 more questions to do, but you have 4 minutes left. So because of that, a stress of pressure is building up you. So as a result of that, you will, even though you do these 2 questions right, but you might mess up most of these questions even though they are so easy. But let's assume that if you are very concerned about your time management, you do these questions within 10 minutes and then you skip these 2 questions for a while. You will lose 2 marks because it's spending 3 minutes doesn't mean that you get 3 marks. Still is 1 mark there. So you will lose 2 marks, but then you will finish these questions. You know that these questions you can finish within 4 minutes. Now you have spent 14 minutes and you have 6 minutes left, but only 2 questions you are supposed to do. So that gives you extra confidence. As a result of that, you will get these questions you will solve this question less than 6 minute time period. The reason is your confidence is high. So that means you have to be a little bit tricky when you are doing the paper, because these type of things are there in the paper to build your pressure and everything. It will check how you can manage the exam stress and all those stuff. Right, let's go to our question number 9. Question number 9, they're asking, so you can see it's again a calculation question. What is the percentage composition by mass of nitrogen in ammonium sulfate? Okay, so first we have to find the molar weight of ammonium sulfate. If you take ammonium sulfate, so we have ammonium group. So let's find the molar weight of ammonium. Nitrogen is 14. Yes, here is molar weight is 14. Hydrogen is 1. Okay, there are 4 of them. 14 plus 4 of hydrogen is 18. Why I did this one? When I see a bracket thing in a formula, I always solve first the bracket. So then we have NH4 is 18. There are 2 of them. So I write 18 times 2 plus sulfur is there. Sulfur is 32.1, and oxygen is 16. So we have, yes, oxygen is 16 times 4. There are 4 oxygen, right? So when I do this calculation, I'll get 132.1. Now what they're asking is, what is the percentage composition by mass of nitrogen? The whole thing is 132.1. So the mass of nitrogen is, we have 2 nitrogen atoms because NH4 times 2. Since we have 2 nitrogen atoms, 1 nitrogen atom is 14. So 2 of them will be 28. So I have to write the mass of nitrogen on top. Mass of nitrogen divided by total mass into 100, which will give me mass percentage of nitrogen of the sample. So let's do the math. We have 2 nitrogen atoms, so it will be 14 times 2, which is 28, divided by total mass of the formula is 132.1 times 100. If you do this calculation, you will get your answer as 21.2%, which means our answer is FB. Right, let's go for question number 10. If you go for question number 10, what is the total number of ions in 10 grams of iron sulfate? Okay, they have given molar weight, molar mass, and the Avogadro's constant. So remember, to find the number of ions, first you have to find number of moles. So first we'll find number of iron 3 sulfate, or we call it ferric sulfate moles. How to find ferric sulfate moles? Number of moles equals mass given divided by molar mass. Mass is given 10 grams. Molar mass 399.9 grams per mole. If you do this calculation, the number of moles you have here is 0.025 moles. This says number of moles of Fe2 SO4 thrice is this much. Remember that if you have one mole of Fe2 SO4 thrice, how many ions do we have? So if I break this Fe2 SO4 thrice into ions, so I will get, here we have Fe3 plus ion, another Fe3 plus ion, 3 SO4 2 minus ions. Okay, that's what we get. So that means if I put 1 mole of FeSO4 thrice, I'll get 1, 2, 3, 4, 5 moles of ions. So they're asking number of moles of ions, total number of ions. Alright, so if I want to find number of moles of ions, therefore total number of moles of ions. How to find total number of moles of ions? You get the number of moles of Fe2SO4 thrice, which we just found, 0.025. We have to multiply that by 5 because 1 mole of it has 5 ions. So therefore 0.025 mole of it will have 5 times that main number of ions. So if we find the number of moles of iron, it will be 0.125 moles. Now I have the total number of moles of ions, but they are not asking the total number of moles of iron. They are asking number of ions. To find the number of ions, there is an equation. Number of ions equals number of moles of ions times Avogadro constant. If I do it, so number of ions equals number of moles of ions is 0.125 moles. We have to multiply that by Avogadro's constant. So what is the Avogadro's constant? We have it here. Multiplied by 6.02 into 10 to power 23 per mole is the unit. Also, when you have per mole unit, the unit will cancel out, because when you count something, you don't put unit. When you are counting chairs, you just simply start counting 1, 2, 3, 4. You never say 1 mole or anything. You don't put any unit when you are counting something. So therefore number of ions we have here is 7.5 into 10 to the power 22. So we have that answer here as D. So we finished the first 10 MCQs of this 2026 January Unit 1 paper. So I'm going to continue adding more and more videos each day, so discussing the whole paper. So simply what you have to do is, if you find this is useful, you just either put a like to this video or just put a comment. So I'll release the next part of this video tomorrow. So if you keep on commenting and if you keep on liking this one, I'll keep on doing all the papers 2026 January and keep on doing till backward, as well as this sitting 2026 May June exam also. I'll start discussing papers like this. Thank you very much.